Hi students, I hope you're doing well. Go ahead and set up your notebook. The Cornell Notes title today is How Electromagnets Can Be Used. In this video we'll talk about how electromagnets are devices all around us and how they are useful. I will do a short lecture first, and then you will have time at the end to copy all the notes and summary at the end of the video. Okay? This is a good time to stop the video if you need to write the title. Let's begin. Let's start by talking about Michael Faraday. Michael Faraday, if you don't remember from the last lesson, was a scientist who discovered that when there's magnetism, you can create voltage or electricity. So this was a digital lab, and then you should should have moved around the magnet, and you should have seen that voltage is created, as you can see in the light bulb, as the magnets move back and forth. So magnetism and electricity are related. You can use magnets to generate electricity, or you can use electricity to create temporary magnets called electromagnets. So most of the electricity you're probably using right now is being generated by humongous generators like this one right here. Generators, if you would open one up inside, have permanent magnets like these right here, and then they have coils of copper wire, and then when a force is applied and it moves the copper wire coils, it creates electricity. So you need mechanical motion to move those copper coils, and that creates an electrical current. And that's how most electricity is made, by an electric generator. And then the opposite is if you use electricity, like from this chemical reaction within this battery. Here in this demonstration, electricity is being used to create mechanical energy. So that's a motor. So a generator, like this one, and a motor are complete opposites. A motor uses electricity to make mechanical motion to move something, like let's say like a Tesla car or other car that uses an electric motor. And then a generator uses motion from a moving river or other source to create electricity. Okay, aside from this, how is this idea or relationship between magnets and electromagnets important? Well, electromagnets and magnets can be also used to make sound. If you're hearing me count my voice out of speaker or headphones, speakers and headphones are basically the same thing, except for headphones are small speakers that can fit in your ear. They also rely on magnets and electromagnets. Here's how it works. So let's say this speaker here has a permanent magnet, and then here there's a coil of copper wire, and then this material, the speaker cone, can be made out of paper, cardboard, or other materials. Plug in your headphones to, let's say, a computer, your iPad, or your phone. It sends electrical signals constantly. This signal turns on and off, on and off. That creates the electromagnet here to become temporarily magnetized, and then turns off. So it turns on and off. It's animation. So when the circuit is complete, because let's say your iPad is sending an electrical signal to complete the circuit, and then the electromagnet becomes magnetized temporarily on and off real quick. It is pushed back because of the magnet, because of the repulsion force, and then when the electromagnet and the magnet move back and forth, they push up the cone, which could be made of paper, as I mentioned before, and that pushes air, which makes the sound waves that you hear when you listen to music or any other sound. Microphone is actually the opposite. So if you were to cut open a microphone, you would see a diaphragm, and when you talk, you make the speaker vibrate a little bit. Although it doesn't act like a speaker, it moves back and forth, creating that electrical signal, which then goes to the recording source. So microphone is the opposite than a speaker, but it has the same components. Alright, that is the end of the video, so go ahead and let me review the notes. There you are. Those are the notes for today. Make sure you have your summary and advanced question at the end. Have a great day. Bye.